Hey everybody, you're with Darren White and Ben Brown in Quartz Lab tonight, and we're just working on the CNC mill that I built a long time ago to do some circuit board milling. So here's what we've got going so far. This is a long ago project that's been dug up and sort of we're trying to do a refit on it from a circuit perspective. Here's what we got. So basically, this is a box slide design. This is a 3-axis CNC mill. We've got some stepper motors here, some really hacked up thrust bearings out of plastic. You can see that I'm using 1/4 rod here, and down here I've been using box slides made out of I believe this is 3 1/4 by 1/4 inch cold rolled steel. And you can see right in here we've got the gibs that are pressed up against the Z-axis here. So the idea here is that you have this mill where this axis, the Z-axis, controls the depth of the cut of, in this case, a Dremel, which will be our cutting tool. Right now we're just using a pen to draw circles, but that's the idea, is that you would have a cutting tool in here. There's also an X-axis over here which drives the table in this direction. And then riding on top of that is a Y-axis, similar design here. Again, a box slide down underneath, going the screws going through that piece of 5/8 square brass stock. And so that's moving the table in this orientation. So with those 3 degrees of freedom, you're able to actually make a lot of different things. On the okay, here's a pretty horrific scene. This is the driver circuit from long ago. I was just using an LR driver here. This is the dead simplest driver that you can use to drive stepper motors. So giant power resistors, Darlington tip 120s, and these steppers are unipolar. So you can drive them in a very simple way here. I've got some LEDs to show status. All of it's being powered off of a PC power supply. So I've got, I'm putting 12 volts to the motor, and the logic over here has 5 volts. On the to actually drive this mill, thanks to Ben, I've got a DOS machine here. This laptop is running Turbo CNC, which is a fantastic program. It's DOS based though, so that's why I needed that. And because I have such a simple drive circuit over here, I needed something on the PC side that I could drive with by specifying the waveforms. Let me just show you in the configuration. I'll just go configure an axis, and you can see right here where I'm actually defining the wave pattern. So this is specific to my motor configuration, and this is like a 4-phase drive here. And I can actually specify what pins. These pins correspond to pins on the parallel port. There's 8 data pins, and then there's 4 control pins out. So that's how you get your 12 pins of control, 4 for each of the motors. So this is just a little bit of sample G-code. G-code looks really simple. It's it's as simple as HTML, very verbose. And in this case, I'm just drawing a number of circles at different positions. So G00, for instance, just says go to a certain position at a Sika position, and then G01 is move into that position at a slower rate. Probably aren't technically the terms, but this is basically how it works. And then the G02 is a command here with the I2 and J0 that I'm using to draw the circles. So why don't we go ahead and we'll just go ahead and run this. Now we're going to do a single cycle of this piece of work, and we'll kind of have a look at the mill. Hopefully the mill's not going to eat the piece of paper in here. So here we go. So the tool is dropping down now onto the paper. And now just kind of running, as you can see from this other circle that we drew earlier, the table isn't completely leveled, so we're, as Gus would say, we're tramming this machine. And you can see here's the x-axis, and and then here's the y-axis moving. And they kind of have a cool symbiosis when they're drawing a circle, because as one speeds up, the other one slows down, and then they reverse that in order to be able to draw the circle. Let me see if I can get that circle in there at the same time. Now that x-axis motor's chirping a little bit, and I've got some investigation to do to figure out what's happening there. I think what might be happening, that chirping's an indication to me that it's dropping steps, which is causing some inaccuracies. And we might see that when we finish up the circle here, perhaps not quite in the same position that we started. So let's see how we did. Hopefully for the video, pretty good. Yeah, so you can see the, I don't know if this shows up in the video, but there's about a 1/16 of an inch gap there. So we just got I got some more work to do in figuring that out. And part of that is going to be rebuilding this driver circuit. You can see over in the driver circuit here, I'm not sure if you can see this, but we've got some status LEDs here that are that light up to sort of help me understand what state. So you can see the Z-axis isn't moving at all here, and they're kind of moving at different frequencies. So that is where we're at tonight with the kwartzlab circuit board mill in progress, work in progress. I'd like to thank Ben Brown for his help. Thanks a lot, Ben. Come around and see us sometime. Tuesday nights are open night, 7 till 10, kwartzlab, 283 Duke Street West in Kitchener. Take care.